we discussed yesterday, let me take the same example. So you have a bank, for instance, for a bank, when the customer visits the bank, so the customer has to provide some kind of details first. Okay, so I am taking a table. So my table contains some fields like customer ID and the customer name and some address and the mobile number and mail ID and all. Okay, so now this is the information I am entering into this table. So after I got the customer details, so next day onwards, once the account is activated, so you will do some kind of transaction, right? The transaction can be deposit, it can be withdraw, it can be a personal loan transaction, credit card transaction, it can be anything, right? So let us suppose I am taking one, so it can be deposit. So a customer may do multiple deposits, right? So he may do some $10,000 on one day, another day he may do some $50,000. Okay. So now here what you are doing is, since to track the deposit details and to maintain the history of these deposit details, you are unnecessarily repeating the ID and name address again. So your ID can be some 100 and 101 I am giving. Your name can be some value and address can be New Jersey, mobile can be 700 something. Okay, so mail ID, I have some mail ID, right? So now to track the history of these deposits, you are unnecessarily repeating the sum of the attributes, right? So instead of repeating the attributes again and again, so what the clients or what we will follow in our real-time databases is, we will just divide the transactions into one table and referential information to another table. So this is called referential information. So I just want to know who made this deposit and all. So to know this kind of referential information, I have the details like this. Okay, so I am unnecessarily repeating the values here. That's why what I will do is I will just cut this field here. I don't use the deposit in this dimension table. I will take separate table. So my table name is called some transaction table. Okay, table name is called transactions table. Okay, so in the transactions table, okay, in the transaction table, I am taking a field. My field name is called customer ID, and I have one more field name is called deposit. So now what I will do, instead of repeating enter values here, I will just repeat the ID and deposit, right? And again one more ID, one more deposit. Similarly, the same customer may do multiple deposits also, right? So now what I can do here is, instead of repeating the values multiple times like this table, okay, I will just take the reference here, okay, customer ID as a reference from the dimension table, and I will just insert all the transaction. It can be deposit amount. I can also add one more field. My field name can be some withdraw amount. Okay, so it can be anything, right? So like that I am taking two types of tables here. This is called dimension table, this is called fact table. This dimension table contains only referential information. That means what is the customer ID, name, address and all. Okay, this is called contextual information. This is, so there is no without, if you take this fact value here, so the deposit the deposit was made by a customer. Okay, since there is no existence of the customer here, okay, since there is no existence of the customer here, there is no deposit. So if I want to insert the deposit value into the fact table, okay, the customer should be existed in the dimension table first, right? So now this is called a fact. So why I am calling this as a fact is, if I want to measure my business performance, like, how can you measure your business performance in terms of numbers only, right? So like how many number of customers we have in a year, or how much profit you got in a quarter, right? And how many how much deposit made by each customer, who is the customer, who made the maximum deposit and maximum withdrawal amount, maximum transaction amount. Okay, so any kind of analysis depends on the numerical value only. So how many, how much, how many days and all, right? So now if you want to do any kind of analysis, you have to do the analysis on the numerical values. So I have numerical values here. The transaction values I have here. Okay, so these transaction values I am calling as facts, because these are the actual facts. Based on these facts only I am able to measure my business performance, and I am able to take the decisions, right? And if we take these values, so with the help of this name I cannot measure my business. With the help of this address I can measure my business, and with the help of this mobile number also I cannot measure my business, right? So this information is required for referential purpose only, and I don't use this information to measure my business performance, right? To know the how many number of customers I have in a quarter, this information is not required for me. This information is not enough. ID is not ID is enough for me. And similarly, to know the maximum deposit made by the customer, this information is enough for me. I don't need the dimensional information. Okay, that is why I am calling this information as a fact, and this one as a dimension. Okay, like that, so for a dimension you may have multiple fact tables. You have some transaction table, you may have some time dimension tables. Okay, so based on your requirement you may have some balances table and some credits table, loans table. So all these tables are fact tables, because this credit table can be used for analysis, and balances table also can be used for analysis, right? And a loans table also can be used for analysis. But if we take this dimension table, my table name is called customer table here. This customer table may not be required to do some kind of analysis, right? So that is why in a data warehousing field, we will divide the data into two kinds of tables. One is the dimension table, and another one is the fact table. Got it?
Yeah.
Yeah, good. So now we will continue about remaining concepts. So I told you like yesterday I told you like we will discuss about SCD concept today, right? Slowly changing dimension. So before talking about this SCD, 1 minute. Yes. Yeah, till here we discussed yesterday. So now before talking about this SCD concept today, so we will see what is SCD and all. Slowly changing dimension. This is important concept in real-time applications. Like if you use any ETL tool, you have to use the approach. Slowly changing dimension. So now let me take the same example here. Okay. So I'm deleting this one. I don't need this one for this example. Okay. So I have the table. This table name is called as customer table. Right. So here, see, this is 100. This is Murthy, and this is New York, and this is California. This is 105. And here I'm taking like right. So mobile number can be anything, mail ID can be anything, right? So now I see I have an instance. I mean for an instance I have some requirement here. See, some of the times my customers may get changed his address. Like here I have fields like I have customer ID, name and address field here. Okay, so in the address field I have some locations of each customer. This is a dimension now. So now after few days, my customer 101, okay, with the name Mamta can change the address, right? From New Jersey to New York, she may get changed, right? So now if the customer changes his address, okay, whether you want to update the New Jersey value to New York, or whether you want to insert the new record for the new address. This is the question here. So this is the dimension. This dimension will change it frequently. Okay, very frequently. So since this dimension will be changing slowly, I will call this dimension the slowly changing dimension, because I have some address field here. So this address will be changed very frequently. It is not daily change actually. So very frequently it will change, and slowly it will change. That's why I will call this dimension as slowly changing dimension, right? Similarly, mobile number also you can change slowly, and mail ID also. So any dimension it can be changed slowly. I will call this dimension as slowly changing dimension. So now if your customer changes his address, okay, so what you can do is the first option is some of the clients will update the value of the old address with the new value, new address. Okay, this is one type of update. Okay, but in my data warehouse, this is not recommended, right? I have to keep track of the entire history. I should not update the existing value. So now I am updating this New Jersey value with the New York value because my customer changes his address to New Jersey to New York, right? So now this is called type 1. So I am not maintaining any history here. Okay, so we have three types in a CD, right? So in slowly changing dimension, so these are dimensions whose attributes change over a period of time. Okay, so periodically this will be changing, right? So that's why we will call this as slowly changing dimension. We have three types in this slowly changing dimension: type 1, type 2, type 3. Okay, so in the type 1, we don't maintain any history, right? We are not required to track the previous changes, right? We will just update the existing value with the new value, like this. I update New Jersey to New York. Similarly, in case if this customer has changed his address New York to California, we have to update the value New York to California with the update statement. Okay, so this is called type 1. Coming to type 2, so instead of updating the value, what I will do in type 2 is for each change I will add a new row. Whenever there is a change, I will add a new row. So here how I can add the new row here is, so my original value is New Jersey, right? So now this customer changes the address from New Jersey to New York, right? So I will insert one more row here, okay, with the same name. So I will add the new address like New York, right? And the same mobile number, okay, and same email ID, right? So this is what I am entering a new record for the new change. Similarly, in case if this customer enters changes his address from New York to some California or some other state, I will insert one more record for this customer. So in case if the same customer 101 changes his address again I will enter the one more row for the new address, right? So like this, for each change you have to enter the new record here. This is called SSCyient type 2. So here what I will do in SSCyient type 2 is for each change I will add a new row, right? This is called SSCyient type 2. So in our real-time applications we will use SSCyient type 2 only. In database use the SSCyient type 2 only. Okay, SSCyient type 1 generally we don't use. SSCyient type 2 we will use because we have to track the entire history. Like that, for each change of the dimension we have to insert the new record in the dimension table, right? So coming to SSCyient type 3, so in type 3 what I will do is I will maintain only partial history here. So partial history in the sense, see here, so for this change in SSCyient type 2, this is the first record, right? So again she changes his address to some New York. I inserted one more record. If again the address got changed, I will insert one more record, right? I will insert one more record since the address got changed, right? So I am inserting California here. Okay. So now, so in case if the customer again changes the address, again I have to insert new record. But coming to the SCD type 3, I don't insert any new row. For each change, we don't insert any new row here. So what we will do is, this is the original record, right? So here I will add a new field. My field name is called address old. Okay, so I will add one more field here. So for the first change, I have only New Jersey as the first value, so the address old will be blank, null value. Okay, now in case the address got changed from New Jersey to New York, this New Jersey I will insert in the address old, and the new address I will add in the address field, right? In case the customer again changes the address from New Jersey to some California, then what I will use this New York I will add in the address whole field, and here I will add the latest address like California. That means you are not tracking entire history, you are tracking only latest history. Only partial history you are maintaining in a new field. Old history you are not maintaining here. So that is called history type 3. Okay. In the type 3, we add a new column whenever there is a change. Okay. So we are not maintaining history in terms of records like history type 2 here. In type 3, we will add a new row. Sorry, new column for each change. In type 2, we will add a new row. This is the difference. In type 1, we don't maintain any history, we will update the value. Okay. And type 2 will maintain history in the form of records. In type 3, we will maintain history in the form of fields. Okay. So next one is ETL operations. So this is what our job, right? Regularly. So what is ETL? ETL stands for extraction, transformation, loading, as we discussed in a demo session. Okay. So with the help of any ETL tool, we can do the ETL operation. So ETL stands for you can extract data from the multiple OLTP systems and perform the business rules. This is called transformation, and load into the data warehouses. This is called ETL operation. Okay. So next one is this is the architecture of ETL operation. So we already repeated in above presentation also. So there also we saw the same architecture, right? So here also ETL will be involving. Okay. So ETL tools will be involved while extraction of data and while doing the transformation and while loading into the warehouses. Okay. So ETL tools can do the extraction operation, cleansing, transformation, validation, loading, scheduling and all, reprocessing and all. All the things you have to do with the help of this ETL tools only. Okay. So and next one is difference between OLAP and OLTP. So in the first session we discussed about OLAP and OLTP. So OLAP is the online analytical processing. OLTP
Hello? 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 Hello?
am I audible?
Yes.
Yeah, fine. Okay. So see, this difference between this OLAP and OLTP. So we discussed a bit about these two concepts in our first session about OLTP and OLAP. So here also I just include all the differences. So OLAP is used for analysis purpose. The OLTP is used for real-time transaction purpose. So all the real-time business operations will be captured by OLTP first, and then will be moved to OLAP from OLTP, right? With the alpha PTL tools. Second difference is, so here, so we have some bulk loads and large amount of data, because OLAP is a warehouse system. It will maintain the entire history of the transaction. That is why here we will contain bulk loads of data. Here we will contain only a small amount of records. Okay. So now next one is here. So in the warehouse system, since my warehouse system is used for analysis purpose and for reporting purpose, you have to load the valid data and consistent data in the warehouse system, right? So there won't be no kind of no real-time validations. Real-time validations are included in the OLTP databases only. Here, I will load only aggregated data. Okay. So here, in OLTP systems, thousands of users can interact with the OLTP systems because databases can be used by thousands of customers. But here, if you see OLAP, so OLAP systems, can be accessed by few users only, because this OLAP can be accessed by business users only for reporting purpose. Okay. Next one is, here we have multi-dimensional data structure. Here we have non-linear data structure. So since I have very less number of records in my OLTP, indexes are few here. And coming to warehouses, since I have more number of records, okay, you have to create the many indexes for extraction and loading purpose, right? Because we have history here. So if you want to maintain the history, since you are dealing with the large number of records, you have to maintain the index. So next one is, so since I have more tables here, like I am following normalized structure here. Normalized in the sense, you will break the table into multiple tables for to avoid the redundancy in OLTP systems. You will create multiple tables. That's why you have to use the more joins. But if you see data warehouse here I have only few giants. I have only fact table and dimension table. That's why I have few giants here since I have less tables. So next one is here I have some aggregated data. I have less aggregated in OLTP system. So coming to OLTP here, so number of edges are very few in OLTP, and we have more edges in OLTP, right? So here we don't do any kind of updates. In OLTP systems, periodically we will do the update operation. Coming to OLTP, so daily we will get the data here, right? So this handles real-time transaction. That's why. So we have to perform more updates because it maintains current data only. Okay. So coming to next thing here, OLTP contains high values of data. This contains small values of data, right? So SCDs I repeated again here for better understandability. So you can just go through this thing.
One question.
Yeah, yeah,
Uh, are OLAP and data warehouse the same thing?
yeah, same thing.
Okay.
So data warehouse is the logical concept, data warehouse is the relational database concept. So I will call this concept as the OLAP system because, the data which is resided in the data warehouse can be used for analysis purpose. That's why we are calling this warehouse as the OLAP systems. Okay, and database we will call as OLTP systems. So next one is SCDs I included here for better readability. You can just go through SCD with an example. This is SCD type 2. If you see here, so I have the customer, my customer ID is some 111002. Okay, so frequently changing his status and his city. If you see here, so in September 23rd, 2004, his status was single. Okay, so after that, in case if the status is changed single to married, so I am entering a new record here on October 25th. Okay, his status is married and his location is same, city is same in both cases. And next transaction he changed his city to some San Francisco, right? Here I am changing his city. So this entire history I am tracking with the alpha of the surrogate key here. If you see the surrogate key here, so since my customer ID is the primary key here. Okay, so since I am entering repeating values in my customer ID, right? So what I will do is I will insert one more field. I will add one more field to the to my database table here. The field name is called surrogate key. Surrogate key serves as the primary key because my customer ID is entering with duplicate values here. Okay, so actually my customer ID is the primary key, but it is allowing the duplicate values. That's why. So for serving the primary key purpose, you will add the new field in your SCD type 2 table. The new field name is called as surrogate key or surrogate ID. Okay, here I will enter a sequence number. If you see here, my customer ID is 111002. The first transaction is 110002 1. Second change is 110002 2. Third change is 110002. Keep the track of the history of the customer with the alpha of this surrogate key. Coming to type 3 here, so type 3, for each change I am entering a new value. Sorry, new value in the old status here. So this is the actual latest status. This is the old status. Okay, this is the actual current city. This is the old city. So like that, I will maintain the history with the alpha of the fields here, with the alpha of the records here. This is called SCD type 3 because these SCDs are not required for you. So only SCD type 2 is required because in our real-time applications, so you will use SCD type 2 only. In case if you attend any interviews in future, you will get questions in SCDs in data warehousing field. What is SCD types of SCD and all. Okay. So next one is coming to fact table. So this is the primary table in our dimensional model. Fact table contains some numerical measurements, numerical values. Okay, so if you see here, see measures in the sense quantity is one measure, count, amount, percent, right? So almost all facts can be numerical values which can be foreign keys. So this is the example of the facts actually. So I have a fact table.
One
My fact
question.
table, yeah, yeah.
Uh, in type 3, right? Can you go to in type 3, SCD type 3?
Yeah.
Okay. There is only one record, right? For if we change the status. So do we
Yeah.
need a surrogate key over there?
that is not required. So that is optional actually. So if you want, you can use the surrogate key, otherwise you can remove it. So since I have example here, I included here, so you can ignore this surrogate ID. This is not required in type 3. Okay. So next one is here, yeah, coming to fact table. So this is the fact table example. So my fact table name is called daily sales fact table in a mart. Okay. So I have date key as the foreign key, I have product key as the foreign key, and store key as a foreign key, because for date key I have one date dimension field, one date dimension table, right? So this date is referring the date value of the date dimension. Similarly, this product key will refer the actual product key of the product dimension table. Store key will refer the actual store key of the store dimension table, right? So this table is deriving from the multiple dimension table. This is called a fact table, right? So in this fact table, I have a numerical values called quantity sold and dollar sales amount. So with the help of these two values only, I can measure my store performance, right, or mod performance. That is why I am calling these two as the facts, right? So we have types of facts here. We have some numerical facts, aggregation facts, additive facts, granularity facts. Granularity with all of depth is called granularity, and that is not required for you. So numerical value, all numerical values are facts, and the numerical values can be aggregated and can be edited. Okay. So next one is here. I just included theory some about semi-additive fact, non-additive fact. This is not required for this is optional theory. If you want, you can go through this. If you want to become any subject matter expert in data warehousing or business analyst in data warehousing, you can go through this content. Otherwise, series are enough for this data warehousing concepts. Remaining is not required. Coming to schema. Schema is very important here. So schema, what is the schema first? Right? So in any database systems, you may have multiple tables, right? So collection of all the tables are called as a schema. So I have dimension tables in my data warehouse. Similarly, I may have fact tables in my table. Okay. So now, if you combine these dimensions and facts, you will get the report, right? So now, to get the reports or to perform the ETL operations, you have to combine the multiple dimensions and facts. This is called schema. Okay. So collection of related tables is called a schema. So we have three types of schemas in our data warehouse. We have star schema, snowflake schema, fact cancellation schema, or galaxy schema. Okay. So if you see here, this is called star schema. So I have some store dimension here. Okay. I have some store dimension here, and I have some product dimension, time dimension, right? So store dimension contains store ID, store name, and chain value. Product dimension contains product ID, item, brand. Time dimension contains time ID, date, and year. Okay. So if you take the sales facts table here, so I have a foreign key in my sales facts table. The key value is product ID. Foreign key product ID. So this product ID is getting derived from the product ID of the product description. Similarly, if you take foreign key store ID here, this store ID is the value of the store ID in the store dimension, and time ID is the value of the time ID in the time dimension, right? So units is the actual fact here, dollars is the actual fact here, right? So I am collecting dimension table multiple. I am collecting multiple dimension table along with the fact table. This is called star schema, because if you see this diagram, this resembles a star symbol. Okay, this diagram resembles a star symbol. That is why I will call this schema as star schema. Okay, so in a star schema, a fact table will be surrounded by multiple dimension tables. Okay, so if you want to build any data warehousing model, you have to follow either star schema or snowflake schema or fact cancellation schema or galaxy schema. Okay, so 99% of the applications are following star schema only. You will have one fact table, and you may see the multiple dimension table surrounded by fact table. This is what will form the relationship. This is called star schema. So next one is snowflake schema. So here, so snowflake schema, star schema one, but the only difference here is here also you have one fact table with multiple dimension table surrounded by fact tables. But the difference here is so I have a dimension table here, right? So for a dimension table, I may have another dimension as parent table. Okay, so this is one dimension table. For this dimension, I may have another dimension as parent. This is one dimension, another dimension as the parent. If we take this dimension also, this is a dimension table. For this dimension, I may have another dimension as the parent, another dimension as the parent. Okay, so this is what you may have the dimension table as the parent for a fact table. This is called snowflake schema. So this snowflake schema is a bit complex schema. So if you have a huge number of transactions, and if you have a complex business applications in your client, then only you have to go for this snowflake schema. Okay, because if you go for the snowflake schema, your tables will be more, right? So again you have to do the more join operation, you have to create more indexes. Okay, so that is different kind of story. You have to do some kind of complex things in snowflake schema. That's why star schema is recommended. Okay, so we will follow star schema only in data warehouse, because anyhow this schema design can be taken care by your designer or architect of the project. So develop as a developer, you do not learn these schemas, but in case if you get chance to become a designer in our future, you should know basic things about schema. That's why I included here. Okay, so next one is coming to galaxy schema here. So here if you see star schema and snowflake schema, I have only one fact table here, but if you see here I have multiple fact tables, two fact tables I have interrelated with the help of these dimension tables again. This is called galaxy schema. Okay, similarly the same thing you can also call a fact constellation schema. In the fact constellation schema you can see the multiple fact tables with multiple dimension tables. Okay, this is also called as galaxy schema. Both are same, there won't be much differences. Okay, so this is about types of schemas. So differences are included here. So what is star schema, advantages of star schema, okay, and what is snowflake schema, right? Advantages of snowflake schema, disadvantages are included here. So differences also included here. What is star schema, snowflake schema? In star schema, so we have some normalizations concept in databases. If you are aware of the normalizations in RDBMS theory, so the same normalization we will follow in data warehouses also. So in star schema, we will follow second normal form. In snowflake schema, we will follow third normal form. Okay. So coming to giant schema, we will use only few giants, because since I am following second normal form here, I have very less number of tables in star schema. That is why giants are few in my star schema. Coming to snowflake schema here, I have more tables here to join. That's why I have to use more number of giants here. Sorry. And coming to query performance, since I have less number of giants here, so less number of foreign keys I will have, query execution time is lesser, so I have good performance here. Coming to this snowflake schema, since I have more tables here, I have to use the more foreign keys to join purpose, and it takes more execution time. Okay, next one is easy to maintain, because since I have less number of tables here, it is very easy to maintain the star schema, snowflake schema. Next one is types of data warehouse. So it is good to use for small data warehouse or small data marts. If you have the large data warehouse, it is good to use the large data warehouses. Okay, coming to dimension tables, it contains only single dimension table. And coming to this snowflake schema, as I told earlier, since it has the parent table for each dimension, it contains more dimension table, more than one dimension table. Okay, so for your reference, I just included differences of first normal form, second normal form also. So this is not part of our training actually, but I just included here. So because in databases theory you will already aware of, you are already aware of this first normal form, I think second normal form, third normal form, because this is the theory of RDBMS. Okay, so what is first normal form, second normal form, third normal form included. So anyhow, these theory is not required for you to clear any interview or to work on any practical scenarios. But the thing is, so if you want to become a subject matter expert, this theory is required for you. Okay, so you can just go through this types of normal forms also. Right. So coming to the difference here. So what is the difference between ER model and dimensional model? So ER model in the sense, if you want to build a database, so you have to follow the ER design in databases. And if you want to build a data warehouse, you have to follow the dimensional modeling. Okay, so this is ER model, this is dimensional model, right? So ER model will be followed by the OLTP systems or database systems, and the dimensional model will be followed by the data warehouse systems. Okay, differences are included here. So coming to next thing, what is ODS, operational data source? Sorry, this is wrong. operational data source. Okay, so operational data source in the sense, so this is the source for our ETL tool. Okay, so from where you are picking up the data, this is called operational data source, right? So this will we will also call this operational data source as OLTP, right? So this is a definition of BA. So what is BA under I declared here. Okay, so this is about multidimensional modeling. So the multidimensional modeling is the integral aspect of the online analysis processing. Okay, so all the ETL tools, I mean all the data warehouses will follow the multi-dimensional modeling only. So this is about data warehouse theory. Okay, so this data warehouse theory is required for you to understand the concept in a better way. This may not be required to work on the real-time applications, but you know, if you just go through this document, it will be really helpful to you to become a subject matter expert in the warehouse concept, or to become a business analyst in the warehouse concept. Whenever you have some time, you know, you can just go through. Otherwise, you can ignore this one also, no issues. So, do you have any questions in data warehousing concepts? Because you know, once you are clear about this data warehousing, I will move to the Abhinishu.
No.
Okay, fine. So yesterday I didn't send you the software, right? So
Yes.
today I will send you the software and the installation screenshot, a screenshot to install the software. And before that, you know, can you know like you have the virtual machine in your laptop to
Sorry.
install the Windows XP?
Sorry, I didn't get you.
No, as I told yesterday, you know, if I have to install the Abhinishu software, so Windows 7, I cannot install the Abhinishu software, right? So I need Windows XP to install the Abhinishu software, right?
Okay.
So if you want to install the Windows XP on Windows 7 machine, so you need virtual machine, right?
Okay.
So to install the software on Windows 7. So you have any virtual machine or you have Windows XP software?
No. No, I don't have any.
No. Okay, so can you download it from Google or do you want me to send the link?
Uh, yeah, you can send me link.
Okay, I can send the link of virtual machine. You can just download the virtual machine from the Google with that link, and you can just download the. I mean, you can just install the virtual machine. After that, you know, you have to install the Windows XP in the virtual machine. Okay,
Okay.
if you can install Windows XP in the virtual machine, so then you can install Ab initio. Even though you can install Ab initio on Windows 7 also, but the issue is Ab initio supports some kind of parallel system, so this parallelism cannot be supported by Windows 7. So we cannot run the parallelism in this Windows 7. That's why better to go for Windows XP for practice.
Okay.
Okay. So Windows XP also I think you can find it from Google. I have the CD here. I cannot send you to. So can you get it from Google? Windows XP ISO file you can download it from Google, I think.
Okay.
Okay. So now I will show you the installation method. So yesterday I thought of showing you, right? So we moved to database and concepts and I didn't show you the installation process, right? So now I will show you how to install the software. Okay. Okay, fine. So yesterday I again installed it. Let me install again. So see, tomorrow onwards we will start the Ab initio basics, right? So better to install the software today or tomorrow whenever you have some time. And Mamata, are you doing MS, right?
Yes.
Yeah. So on which specialization and what is the specialization?
I'm doing MIS,
Okay.
information system.
Okay.
One question. Right now I have Windows 7 in my laptop, right? So I can
Okay.
download that virtual machine VMware, right? And
Yeah.
on top of that, I can
Yeah.
install Avnation, right?
Yes. Yes.
Okay.
So after downloading virtual machine, you know, in the virtual machine you have to install any Windows XP OS again. So Windows XP you have to get. Windows XP CD can you get from any of your friends, right? So
Yeah, I can do that.
yeah, I think in the Google also we can download some image file Windows XP, but it requires some key. That's why better to get the Windows XP CD from someone and install it on virtual machine. And this my some of my friends also did MS in UK and US actually, and they are also working on Avinish in US.
So it doesn't also work on Vista, Windows Vista.
Vista, it will be installed by, I mean, in the we have some options set for any software which can be installed on Windows XP. So for the software installation file, we can just right click on the file and we can just check the, we can, I will show you that. You can just change the settings. I'll show you that. So this is the folder I will send to you. Okay, Abinishon new is the folder I will send to you today. So in this folder, you know, you have the setup file, right? This is a operating system setup file. So if you want to install this on Windows 7 or Windows Vista, what you can do is, you know, you can just right click on the setup file, go to properties option here. Okay, so in the properties you can see some compatibility. In the compatibility, if you select this option, run this program in compatibility mode for some Windows 7 software, it will be installed in Windows 7 also. But the thing is, you know, while we have some advanced concept in this initio. So after a few classes, you know, I will explain about some multi-file system concept. Those kind of multi-file system, with the help of some commands you have to create. Those commands cannot be executed in Windows 7 or Windows Vista. That is the issue. That's why better to go for Windows XP only. Okay, so if you don't get Windows XP for few days, you can install this software on Windows 7 also. You can practice on Windows 7 also. But once we start the multiple system concept, you have to install Windows XP at least that time. Okay, so I install the operating system. I am installing this DD also. So
So
I
if
have to,
one question,
yeah.
if I didn't get XP CD, so can I download from online Google?
Yeah, on Google also you can find out the Windows XP, but I think it needs some key, right? So for
Yeah.
activation, it will ask some key. So I will do one thing. So I will try to send out the image file today. So I have Windows XP software, right? So I will try to send out the image file to you along with the key. Try to download image file and try to install. We will
Okay.
see that. It will work.
Okay. Okay. Thank you.
I will send the file. I think you can download and you can install. Okay, so now I don't have any software here, so I'm installing now. So this is the folder I will send to you. Just open this folder, Abinish new folder. So this is the setup file for cooperating system. So we have Abinish cooperating system and we have Abinish GD also, right? So first we have to install the cooperating system and then we have to install the GD as a second software. Okay, so how to install this setup file is click on the setup file. So the first thing, if you want to install the setup file on Windows 7, you can install. Okay. So how you can install is, you know, just right click on the setup file properties, go to some compatibility option here. Okay. In compatibility, you can see the compatibility mode. Run this program in compatibility mode for. Okay. So since this is Windows XP, I am not able to see the option here. But if we open this folder in Windows 7 software, I mean Windows 7 OS, you can see option here. Run this as a compatibility for Windows XP and all. You can select that one. Okay. So then you can click on the apply OK button. It will run on Windows 7 also. Okay. So now I am installing on Windows XP. Click on setup file. Okay. Click on set. It is extracting the required files. Okay. See, I think Monday onwards, so few more guys are joining our session.
Okay.
So then we may have to change the timings actually. So like as I requested you yesterday. So can you join 7 p.m. IST, right, from Monday onwards? Sorry, 7
Mm,
a.m. IST, not 7 p.m. 7 a.m. IST. Our time 7 a.m. Your time
I think it will be
9:30,
9:30.
9:30, right? Can you join?
Uh,
Because
it's
many
from
guys will
Monday,
be
right?
there.
Is it from
Yeah,
Monday?
Monday, so I will confirm you once. It's
Okay.
from Monday, it will be Monday. 500, because there you may have 2 3 guys. If you have more guys in the session, you can just interact and you can just ask the more questions, right? So if you don't get any questions, if someone asks the questions, you will get it clarified.
Yeah.
That way better to join with the more guys, right? Yeah. So here, see, when I click on the next button, it will ask to accept the license and all. So here you have to select the path of the folder where you want to install the administrative software. So by default it will be installed on C drive like all other programs. If you want, you can change by browsing here. Okay. So I am clicking on next. So it will create some temporary folder for work directory. I mean, for each software it will need some temporary working area, right? So for ab initio also create some temporary working area. So that will be in the C colon ab initio bar. If you want, you can change this one also. Click on next one. Click on next. Okay, it will be extracting and it will install. It's very simple installation. Okay, so in our real-time machines, we have the Unix machines, right? So in our real-time systems, so Unix supports parallelism, Unix supports concurrent user access, right? That's why we will use Unix operating system as a server in real-time machine. So this operating system will be installed on the Unix operating system in real-time application by the ab initio admin. Okay, you need not install the ab initio operating system. Ab initio admin will install the ab initio op on the Unix operating system. And the graphical development tool is there, right? GDE software. I am going to install next after this one. Okay, so GDE you have to install on the local machine, your local machine. Okay, so you will install the GDE in local machine on Windows software, and this scope will be installed on the Unix machine. Okay, you will configure your GDE to run with the Linux machine or Unix machine from Windows to Linux. So there is simple task. We will provide some document to you in our project. With the help of the document, you will configure the GDE. Yeah, it got installed. Okay, so now my code got installed, right? So now to work on the components, I need the GD graphical tool. So this is the graphical tool folder. Open the graphical tool folder. So this can be installed on Windows 7. Windows 7 you can install the GD, but the cope only you cannot install. That's why you have to set the properties of this setup file of operating system to install on Windows 7. But the GD will be installed on Windows 7, no issues. Okay, this is the setup file. Open the setup file. So you have to provide your company name. You can give any name. I'm giving some training here. Okay, this is the destination folder like all other programs. You can browse and you can change. That's it. Simple installation. It will be over. Right. So now we are using GD 1.10 and COPE 2.10 version. But the latest version in the market is 3.1. Okay. So we have few differences between the 2.1 and 3.1. I will explain all the differences while talking about the graphs. Okay, so now my ab initio got installed, right? So I am opening ab initio now. So go to start. You can see ab initio here. You can see the GDE. So this is the called graphical development environment tool I installed just now. Okay, COAP was installed before this tool, right? So now I have to do some configuration in my GDE to connect with the operating system, because as I told you in like real-time machines, your COAP will be installed on the Unix machines or any other server. Okay, So the day before yesterday's session, I showed you some PPT slides, right? So there I told you like we can install the ab initio operating system on native operating system, and the GD will be installed on the local machine, right? So similarly, no, just assume if your COP is installed on the server and if your GD is installed on local machine, you have to configure the GD to connect with the server. Okay, the configuration can be done with the help of the run menu here. Go to run menu, click on settings menu. Okay, so click on edit option here, right? So here this is the path of some profile. By default we take some profile path. You need not edit this one. So go to this method here. So if your operating system is installed on the any other server on remote mission, you know, so you have to use any of the connection method. You have to go for secure shell method, or you have to go for any other connection method, right? Telnet method, REXE method, administrative server method, telnet method, and all. Okay. So generally 99% of the projects you can see secure shell method only to connect with the other host and all. So if you install the operating system on other hosts, you have to pass the host name here. So your host name can be some us dot your host name can be some us dot bk.com. Okay, this can be your host name. So you have to provide some login to connect the host, and password you have to provide here. Okay, but now for now, no, I am not installing this scope on remote server, right? For training purpose I install this scope on my local server only. So this GD and COPE both got installed on local server only, right? That's why I am not selecting any secure shell method here. But in your real-time application you have to follow secure shell method only. I will also show you some screenshot. So I will also provide you some screenshot, okay, how it will be done and that, right? So for now, you know, since I am installing this scope on my local server, right? So I have to use the local anti-host method. So in your mission also you have to follow local anti-host, because you don't have any remote server here. I mean the local server, that is the GD server, that is the COPE server. I'm giving local anti-host here. Next thing is host directory. So host directory is the temporary directory. So where your temporary files will get created. Like, you know, while doing some any internet operations in IE, Internet Explorer and Google Chrome and all, so there are some directories where temporary files will get created, right? Temp folder. Similarly, here also there is one directory, but directory name is C ab initio. So where your temporary files will get created, right? You have to pass the whole directory here. You can give another directory also, no issues. You can do D, E also you can give. The next one is coming to version here. So version is the, you can select the version. So my latest version here is I am using 2.10 operating system here, right? You can select 2.987 and all, because by default the latest version support older versions also. But generally we won't use auto, because automatically it will take the version. Next thing is location. So where you install the ab initio? In C drive only, right? So where you install ab initio is in C drive ab initio folder. That is why. So here you can see the, you have to give the location of the operating system installed. Okay, so next one is shell type. So if you install the operating system on Linux operating system, your Linux supports Korn shell or B shell, C shell and all, right? So then you have to select the Korn shell option here. Korn shell or C shell, you can select it, right? But here, you know, since I installed my operating system on Windows operating system, Windows uses the batch format internally, batch file format, right? So that's why I'm selecting batch file here. By default, you can see batch, because this is Windows operating system. Okay, so you have to just pass the local anti-host here, and you have to just use the host directory. That's it. Remaining will be taken care by ab initio GD automatically. So click on test it. It will verify the settings. Run settings verified. Okay, you are able to connect to operating system now. You can design the application now from the GD. Okay, so from tomorrow onwards, we will discuss about the applications, graph basics. Okay, so I will tell you what is a graph, what is a component, what is a flow, how to connect the components here, so how to run the graphs and all. Tomorrow onwards we will discuss about reading the data from multiple systems and doing transformation and loading into warehouses. So we will discuss about all the components on day by day. So once we are done with all the components, you know, so we can move to COPE concept and we can move to EMA concept. So it takes minimum 3 weeks to complete all these components. 3 to 4 weeks it will take. Okay, so any questions we have? So time is 7, right? So can we discuss tomorrow remaining concepts?
Sure. So tomorrow I will
Free,
have
right?
this, I will have at the same time, right?
Can you come again, please? I didn't get.
Tomorrow I'll have the class at the same time, right?
Yeah, same time, same time.
Okay. And one more thing. I don't have any recording session and materials from the first class. So how do I
Yeah,
get that?
demonstration. Right? I will send you. Yesterday I thought of sending you. I forgot actually. So today I will send you the recording session. So which we discussed in the first demo session along with the slides. And next one is yesterday session you have, right? Yesterday and today you are recording, right, from your side,
Yes.
right? Fine. So data variation content I sent yesterday, right? So today I will send the record session of the demo session, and I will send the screenshots along with the administration software. So how to use the screenshots and the software also, and the VMware link also I will send to you. Okay,
Okay.
fine, right?
And one more thing. Can you send me the
Which
syllabus
one?
for the ab initio?
Uh, Come again, please.
Can you send
Your
me?
voice is bit low actually. That's why.
Can you
Yeah.
send me the syllabus?
Syllabus, right? Got it, got it. I will send you. Today I will send you.
Yes. Sure. Thank
Okay.
you.
I'll send Excel sheet. Yeah. Thank you.
Okay. Bye.
Bye.